So why am I starting off with formula literacy first? Well, in my experience teaching A level, every once in a while a student gets almost irrevocably stuck on a topic. And when they're working back through what they've done, it seems they find it hard to discern between what is a sensible, realistic compound or product from one that is just a random assortment of atoms they have left at the end. And so to me, what this tells me is that their formula literacy is quite low. It's one of those things we assume people have at each stage, but we never necessarily spend time practicing and building it to the point where it becomes automatic. So by spending a little time working on this, yes, some of it will be very familiar to you. If you're a successful student at GCSE, hopefully all of this is nice and easy for you, but at least you know you're ready when you're starting A level. So the first thing I'm going to do is we're going to determine the number of each atom in a formula. And these are very, very easy things sometimes. So, if we take our most obvious ones, H2O and CO2, you should be able to look at them quite comfortably and tell me exactly how many hydrogen, exactly how many oxygen are in there. Okay, we're not going to waste time on that. It's 2 hydrogen, 1 oxygen, 1 carbon, 2 oxygen. We should know that the number points to the left. It's worth remembering that that number doesn't have to be a 2. This is a good opportunity for us to introduce ammonia, make sure everyone is aware of that. It's one of the few molecules you're expected to know its formula just from its name, so it's worth knowing what ammonia is. You should have come across it before, but just to be on the safe side, that's ammonia, 1 nitrogen, 3 hydrogens. If you know your basic rules, hopefully you'll be able to start again. Hopefully you'll be able to take this formula and quickly tell me how many hydrogen, how many sulfur, and how many oxygen there are. We got 2 hydrogen, 1 sulfur, and 4 oxygen. So if we can do that, we know we've got the basic rules of when a number counts. If we want to make the number count to more than one thing, we use brackets. So a good example of this are the group 2 hydroxides that you'll be studying at A level. And here this bracket tells us we got 1 lot of magnesium, but 2 oxygens and 2 hydrogens, because the arrow goes there, and so everything inside the bracket is multiplied by the number outside the bracket. This again can include other numbers, so let's say we consider iron nitrate. Here we've got 2 numbers involved, but the rule is just the same. We're going to have 1 times Fe, we're going to have 2 times nitrogen, and we're going to have 6 times oxygen, because we've got the 2 times the 3. So for all these examples, it becomes fairly straightforward. So that's how we work out the number of each atom in a particular formula. That's not our only problem. We need to be aware of different types of ions. Okay, now you should remember that metal ions are generally explained by the periodic table. +1, +2, +3. And then non-metal ions are also explained by the periodic table, and it's how many the group number needs to add to get to 8. So in this case, we've got a -1, a -2, and a -3. And we tend to ignore group 4, more of a macromolecular problem. Now, what about the transition metals here? You see, I have this group of transition metals that I put a question mark over. How do I know the charge on those ions? Well, that's our first thing we're going to think about today. The charge on a transition metal ion is always told to us by a Roman numeral. So if I have copper 2, I have copper 2+. If I have copper 1, I have copper 1+. If I have iron 3, I have iron 3+. Anytime we get above 3 in these Roman numerals, we then get complex ions. It becomes a little bit more complicated. You'll study them in due course, but for now we just need to remember that. So our transition metal ions are using Roman numerals to make sure we get the right charge on each ion. What about our non-metals? So nitrogen can form something called a nitride ion. And when it has an IDE ending, it's telling us it's just the element on its own. So in this case, it's just an N. And if I look at my periodic table, nitrogen is in group 5, so it's going to be a -3 charged ion. But nitrogen can also form a nitrate. And when it's got the 8 ending, what that's telling us is it's got hidden oxygen. So we've got N and we've got O, and in this case there's 3 O's and it's a minus. And these are things that just need to be learnt. There's nitrate, that's one that's worth learning off by heart. You will also come across carbonate, CO3 2-. You will also have come across sulfate, which is SO4 2-. Now there are 2 other unusual ions that we want to be clear on. One of them is called hydroxide. Now it's got an IDE ending because it's actually got the oxygen already mentioned in it. It's OH-. And the other one is the ammonium ion, NH4+. And a good way of remembering that this is a positive ion is it's got the ium ending like a lot of the metals do, and the metals form positive ions. So if we've got our periodic table and we've got the rule about the Roman numerals and we've got this area of complex ions memorized, then we're going to be fine. These are the kind of things we'll be expecting to make. We're not going to make random things. We're not going to make S3O8. We're going to use simple building blocks that we're familiar with in most of our answers. Now, when we determine the formula from the ions, there's a number of different ways we can do this. So let's take, for example, I've got iron and I've got oxygen. And in this case, if it's iron 2+ and O2-, it's very easy for me to realize that these cancel each other out. So the formula will be FeO, iron 2 oxide. But what about if it's Fe3+ and O2-? Well, in this case, it's a little bit trickier. And so we have a number of different strategies we use to make sure we get the right number of ions in the formula. The first one we can do is we can think of common multiples of each number. So in the 3 times table and the 2 times table, 6 comes up. So we're going to try to get to 6 on both sides. So I'm going to add another 1 here, and I'm going to add another 2 here, and I've got 6 on this side, 6 on this side, so I've got Fe2O3. But sometimes an easier way of doing it is a thing called the crisscross rule. So we've got Fe3+ O2-, and what we do is we swap the numbers. So the iron takes the 2 from the 2-, and the oxide takes the 3 from the 3+, and we get Fe2O3. Exactly the same formula, but a different way of doing it. Now, formula literacy is all about being able to use these tools all the time in lots and lots of different situations. So here I've got some practice for you. I got 25 questions. There they are. Pause the video. Have a go at completing every single question. Then when you're finished, unpause, and I'm going to scroll down and show you the answers. Good luck. So here's the answers. Mark them off. Got a bonus one there for some reason. How did you get on? Again, pause the video if you need to. Double check you've got all of them right. If there's one you haven't got quite right, look at it carefully and think where you've got wrong. It's probably just an application of one of the rules. Feel free to scroll back in the video and watch one of the earlier bits to make sure you get everything right. So that's formula literacy. It takes a lot of practice, little and often, to build up a kind of fluency that makes us successful. When you're doing your problems and you're answering your questions in your exams and in your tests, try to think that the products that are going to be made are going to be relatively sensible. They're not going to rewrite the rules of chemistry. There's no secret amount of chemistry that your teacher doesn't tell you because the exam board says you're not allowed to know it. You are being told everything you need to be successful. So don't improvise too far, stick to the rules and keep it simple. If you found this video helpful, please make sure you like and subscribe to the channel. I'm going to be putting up more content throughout the year, and hopefully by the end of it we'll cover the entire A-level specification. Good luck.